Hi guys, so in the last video we did Biot sarvats law for a straight wire. So in this case we now want to look at a case where the wire is curved. So Biot sarvats law for a curved wire. So in this figure we want to consider a curved wire in form of a perfect circle. So in basic formula, dB is equals to mu naught I sin theta dx over 4 pi r squared. So take a curved wire in form of a circle with the length x. So when you take a differential part of x, it will be dx, a small part of it. So we want to know magnetic field at point P, center of the circle. So when you extend at a small angle, because you took a dx, the small angle extended by the length dx, we take it as d theta. So when dx is made so small, it appears like a tangent to the circle, and the tangent, this theta, the angle between r and dx, becomes 90. So dB, which is mu naught I sin theta dx 4 pi over 4 pi r squared, since sin theta is 90, so it will be sin 90, which is equals to 1. Sin 90, which is equals to 1. So for sin 90 here, we substitute, for sin theta we substitute 1. So dB, for this case, dB will become mu naught I dx over 4 pi r squared. Over 4 pi r squared. So the next step, when we took the small part, since this angle is 90, makes this one to be a right angle triangle. When this becomes 90, this one now becomes a right angle triangle. So for a right angle triangle, we know that tan theta, so in this case we'll take tan theta. This is the theta, this is the theta. Tan theta, which is the same as tan d theta, tan d theta equals to opposite, which is dx over r. So the tan of a small angle is almost the same as the angle itself. If you take, let's say, a tan of 0.01, it will be nearly the same as 0.01. So tan d theta, so we can say that tan d theta is the same as d theta itself. So it will be, so this one will go back here to be d theta is equals to dx over r. So let's make dx the subject of the formula. So dx will be equal to r d theta. So remember where dx was here. So we want to substitute the value of dx with the r d theta. Because dx is equals to r d theta. So dp will be equal to mu naught I r d theta over 4 pi r squared. So by r will go with this squared part, so it will be mu naught I d theta over 4 pi r. So remember, this was dB, but we were asked to get pi. So from here, since we have dB, we want to get b. Integral of dB from 0 to theta. So since we already found dB was, so we'll integrate, and the place for dB we substitute for the values we found, which were mu naught I d theta over 4 pi r. So up to there, the first thing we'll do in this equation, we'll get the constants out and remain with the ones to be integrated. So the constants here will be, where B now will be equal to, the constant is mu naught I over 4 pi r, then integrating from 0 to theta, now it will be the theta. So in this case, B will be equal to mu naught I over 4 pi r. When you integrate, you get theta from 0 to theta. So substituting these ones into the equation, B will be equal to mu naught I over 4 pi r theta. And now this is the equation, the magnetic field equation for a curved wire. So this is, we are talking about the curved wire. So thank you for watching, and the next video we will look into other